generic enums that are sometimes optional. Just kind of a mush of everything that I'm going to talk about. So I was going to initially talk about optionals and just kind of go at what are optionals. By the way, has everybody used Swift at some point? Yeah? Okay. I didn't know if some people are only Objective-C developers. I was going to talk about like what are optionals and like the basic uses in Swift, but I wanted to kind of approach it the way that I do for a lot of things, which is kind of look at the implementation of something to kind of get like the hard facts about how this thing works. And then I realized, and the implementation of that utilizes generics and enums, and after kind of polling around, I realized that generics and enums, at least at our level as kind of CS students, they're a little foggy in a lot of people's minds. And so I wanted to kind of touch on what are generics and enums and give a little bit more than you might get in CS 187, and then kind of utilize both of those to kind of think about what are optionals and how can we use them. So that's what I'm going to do. So I'm going to start with generics, go over an overview of what they are and how you can use them to accomplish different mental models, and then go over enums, especially enums with associated values, and then talk about optionals and how we use generics and enums in optionals. So generics, they're scary. They probably inflict a lot of fear in people's minds of CS 187 and tutoring and whatnot. But they're not all that scary, and I'm kind of try to approach them from not even looking at a generic function. This is a lot of code on screen, but this is actually like one of my first projects. It's the 121 project. If you guys took 121 here, where you just print out your name and age and your height, and like this was the code just brought over from Java, and I mostly just had to delete stuff because it was brought over from Java. But this is kind of what a lot of us will do. We'll just like hard code something in, and then what we'll realize is that we want to use a function in more general ways. We want to say anybody's name. We want to say anybody's age. You can tell that it's my first code because it says I'm 18 and I'm 5'8". I'm actually 5'9" now. So what we do when we want to generalize something, and it's a little bit smaller, the code will kind of shrink and grow as the project goes, or as the slides go on, because of the amount of space. But we like extract values into parameters, right? So we have this function, and it takes in a name and age, a height in feet, and a height in inches, and then we can use those parameters inside of our function. So now our function is slightly more general. This is called like lifting it out of the function. And so this is kind of like how I initially started thinking about how do you generalize things. Moving out of CS 121. If you think about a problem and you want to kind of codify it, you may think a lot about containers. So if you're picking apples, you'll have like an apple picking bag that you might want to model in code, and so you've got an array of this apple type, and you have a function that adds apples into that array of apples. And then maybe you go back to school and you're like, shoot, I need a backpack. So I'm going to model textbooks and their container inside of code. So you've got two classes now that are rather similar. They're based off of the same principles of adding and holding objects inside your class, but they have to be separate because they utilize different types. We extract from there that I should really put that thing in my bag. That's what we think about for both the apple picking case and for the textbook case. In both cases, we've got something that's going to go in our bag. And some of you might see where this is going. We're going to make bag generic over things. So that might look like this. We've got a bag of things, and we have this what's called a generic identifier, like a type identifier. And we put it inside these angle brackets to show that it's something different than other classes. But bag is now this generic class that has an array of just something, some type, and we're gonna add things to it. And whenever we need to add things to this container. So when we want to use that bag, we've got, for let's say apple picking, our original class will look like this, but you can kind of think of thing as this, almost this variable for a type. So when we actually go ahead and run this, you can kind of think of thing as getting replaced by apple, right? So and you can think, yeah, sorry.
So does Swift use type erasure, or how does it?
Yeah, sorry, I've heard type erasure as a term. I'm actually not sure what it is.
So are the types like, is that placeholder type known at runtime, or?
The thing type.
Yeah, the thing.
So when we're coding, like when we compile the code, the thing type isn't known. I don't think at runtime.
It disappears. Yeah.
At compile time, excuse me. Yeah.
That's what.
But when we run it, like it kind of, at least mentally, it gets kind of replaced by this.
Because in Java, you can't directly instantiate like an array of like thing. It'd have to be a concrete type. You could like do an array of objects and cast.
Right.
But it's interesting.
You can have an array of things in Swift.
Mm-hmm. Yeah.
Yes, and you
So
can
that-
put an apple and textbook if they're both things.
Right.
Right. Yeah.
That makes sense. Yeah, I was just.
Is that just an any object then?
So any
Any
object
object is
is
like any.
is kind of a different thing. Any object is like object in Java. It's kind of a superclass over everything. It's like kind of like a superclass. Yeah. So anyways, I think what you can kind of see from this is that we can also do this with textbooks, right? What we can't do is have a bag of nothing. So we can't actually have this bag that's not holding any specific type. We don't actually have containers that can hold heterogeneous types of objects. So that we can't really define a bag that holds apples and textbooks at the same time. So moving on from boring old school to clothing. So this is a little bit of a next step on generics. So let's say you've got a protocol called clothing, and we've got a couple different classes for lights and darks. And we got, let's just say, this other class of rocks to throw in there for the example. We can create a class that is generic over types of objects that implement the clothing protocol. Right now, there's nothing in the clothing protocol, so anything could implement the clothing protocol. But that's what we can kind of do in those generics right there. So clothing item is still the same replaceable identifier, but clothing as the protocol is going to kind of specify what we can put in a washing machine. And then let's say we've got some function that operates on a list of clothing items. What we know we can't do is we can't have a washing machine of rocks, because rock, as we saw in the last slide, didn't implement the clothing protocol. So that's one good thing about this restriction that we've got here. And so what I'm going to kind of go on from here is thinking about generics and how to solve certain problems, and how implementing a certain way will allow you to have different types of, in this case, washing machines, in other cases, different types of objects. But here's the bougie way to wash clothes, right? Here's our clothing protocol, same as before. I'm just putting it up there so you can reference it as you go along. Let's say you have a shirt that you wear specifically for career fairs and a shirt that you wear for parties. There we go. And you've got a washing machine that's only for lights, because you're a bougie computer science engineer, and you can wash your white shirt for career fairs. And this is great because our washing machine takes specifically light clothing items. We can create another dark washing machine that takes only our dark shirts. But what we can't do is in the darks washing machine, wash our white shirt. And in the lights washing machine, we can't wash our dark shirt. So judging on based off of the way that, that we implemented our washing machine above, with it only being able to take one type of item that implements the clothing protocol, we can only have washing machines that implement that take in one type of piece of article of clothing in this case. So if you wanted to model a washing machine that could wash any type of clothing, we can actually use the system that we've defined here. So the way you wash clothes as a college student, right? So we create one washing machine that can wash anything, and we can wash it at the same time. We can wash our white shirt, we can wash our dark shirt. And that's because our Omni washing machine isn't generic over anything. It just takes an array of that protocol. So we can have a heterogeneous, quote unquote, array of pieces of clothing, as long as they all come from this kind of it's not a super type in this case. It's a protocol that we implement. So does that kind of make sense, that distinction that we've had there? And this is the way that you're supposed to wash clothes, where you kind of separate lights and darks. So if we have a no blending colors washing machine, we can make our function specifically generic over clothing items. And then what we can do is create an instance of that washing machine and wash only lights and only darks, but we can't wash both. This is kind of a tough error to look at, but because our type can only be kind of replaced, our clothing item type can only be replaced by one thing at a time, we can only wash lights and then we can only wash darks. So that was kind of a way to, if you have different mental models about how something should work, you can utilize generics and you can utilize any type of construct in programming to kind of model that. Enums. So any last questions about generics? I won't make you implement Tower of Hanoi. Enums. So this is the kind of basic way of thinking about enums. You have a couple different cases. I think about them as different options. And then my major is a way to kind of instantiate one of those enums and have it as a specific option. And then you can think about if we've got a function that operates on a case in our enum, like this function, I have Professor Barrington, we can switch and look at all the different options that we currently have and return true or false based off of those options. And enums are a really powerful way for us to kind of model different problems of like, is it this thing or is it this thing, without having to kind of use stringly typed things. We don't have to just pass in a major as a string and look at it. We can actually kind of specify the discrete set of options. For continuous types of options, we can add what are called associated values to these enums. So BDIC is the build your own major at UMass, for those who don't know. So you can build your own major with an associated type here. I'm just adding iOS app development. And what we can do is kind of look at that value, the focus in this case of this BDIC major, and kind of utilize it in our code. So we can extract it out, look at that focus description, and then based off of the value of it, return true or false.
So here when you case.read, right? So that will contain the focus description.
Yes. So focus description gets replaced by that string that we've got there, and then we can match on the string. Yeah. And in terms of BDIC, this is probably a pretty good way to model it because you could have literally any type of major, right? Whereas for other majors, it is a discrete set. So discrete continuous, right? So this brings us to optionals. Hopefully it will be demystified at this point. So the way that I think about optional, a lot of people describe it as kind of like there's like something in the box. I'm not going to utilize that right now just because you'll read that in other articles and I kind of want to give you another set of context. But I think about it as existence. So if we think about Wi-Fi, right? Wi-Fi is this kind of like you never know if it's there. And that's kind of how I think about optionals. So if we're at the Apple store, like we probably have Wi-Fi, right? This is what our computer kind of looks like. If we're at UMass, like we don't really know. So optionals are a great way to look at Wi-Fi at UMass. Like at this point, and I'm not sure how much you guys have studied the iconography of Mac OS's Wi-Fi system, but when there's no lines, that means that we don't have a Wi-Fi network. When there's so that means that we haven't turned on our Wi-Fi card. That was the wrong way of saying it. So if there's no lines, we haven't turned on the Wi-Fi. If there are lines but they're grayed out, that means we've got no Wi-Fi right now. So in that case, we've got nil. In the top case at the Apple Store, we definitely have Wi-Fi, so we have these darker lines.
What if they're flashing?
If they're flashing, then you should go to IT. And once we have Eduroam, we can have our full bars. So this is kind of a way to check for existence. And optionals help us kind of look at that. So what helped me, and I kind of introduced the talk this way, is looking at the implementation of of different things to learn how they work. So if we look at Apple's implementation of optional, it just kind of looks like this. There's some other cruft in there like documentation, which nobody needs. But this is kind of what it looks like. So what we've got is another enum, kind of like a couple minutes ago, with an associated type, and the value or the type of that associated value is wrapped. So that's our generic identifier. So optionals, like our bag, can be used to contain any sort of type. We have to define that type once we go at runtime. But at compile time, we can think about this wrapped as just like a variable for the type. It's this generic identifier that will get substituted. So when we look at our Wi-Fi network, what I'm kind of trying to show here is that the question mark is just kind of this syntactic sugar here. So we could write Wi-Fi network as an optional, utilizing the syntax on the fourth line there. Swift provides us some syntactic help to just make this a little bit quicker. But what that really means is that we've got some optional type, and our generic identifier is getting replaced with Wi-Fi network. When we have nothing in our Wi-Fi object, that's when we have the none case of our enum. And when we have something, that's when we have the some case, nicely named by some. And so the top, what I'm trying to show there is just this is the way that we can easily syntactically do it using Swift syntax, but we can surely use the long form syntax whenever we want to. And what this kind of alludes to is how we can unpack the optional utilizing a similar switch mechanism that we were doing a couple minutes ago. So if you want to watch the Apple keynote and you don't know if you have a Wi-Fi network, you can look at the Wi-Fi network and switch on it. And if you've got some network, we know that definite Wi-Fi network is a Wi-Fi network. We know it's there. So we can visit apple.com. Visit apple.com is just a function down there that has to have a Wi-Fi network. It was just a placeholder. But if we've got nothing there, we can kind of just return. So the switch, utilizing like, I don't know, 5 or 6 lines, we can kind of unpack the enum. But optionals are kind of a really helpful idea for us in Swift. So to have to write 6 lines all the time would kind of be tough. So Swift will help us with that. And this kind of just to show you, definite Wi-Fi network is of type Wi-Fi network. It's not Wi-Fi network optional. So that allows us, that shows us that we can use it in places where we are required to have a Wi-Fi network.
Sorry, I'm a little confused with that. So this definite Wi-Fi network.
Yeah.
So this is of type Wi-Fi network only, right?
Right.
Okay.
Yeah. So
Not the optional.
if we looked at maybe Wi-Fi network, that would be of the optional, right?
Okay. Cool.
Yeah, and so we wouldn't know. We would have to unpack it to utilize the Wi-Fi network. Visit apple.com, same function as before. What we can think about is how could we simplify this, right? So like I was saying, there was kind of 6 lines there. So how can we simplify it? Well, maybe we should just pass the Wi-Fi network into visit apple.com. And this is a problem because Wi-Fi network is of the optional type. And this is kind of a problem that we'll all encounter when we kind of switch over to Swift from another language, because you're used to you just having to check whether something is null, not nil, or not, and just passing it in and kind of blindly trusting that that it'll work. But in Swift and in other languages that utilize optionals, when you manipulate with that variable, you have to kind of deal with the case of whether it's null or not. It may be annoying, but it's actually kind of a way to make sure that you handle error cases. So you apply the fix-it, which is what Xcode does when they have a circle inside of the red hexagon or octagon, maybe, I don't know. And you apply the fix-it, and it tells you, let's put an exclamation point there. And if you work on my team, I would fail you on your PR, because if I passed in nil into this, we're going to fatal error, and our program is going to crash. And that's because this exclamation point here, it's another kind of syntactic sugar, but it allows us to say, like, I don't care about the case whether it's when there's nothing there, and I'm just going to utilize it. But when I do utilize it, that's when I end up crashing. So what could you do to help with this? You could utilize the Java method, right? So where you check if it's null, and then you know that it's not null because you've entered into this if case. And so then it's safe to kind of put the exclamation point there. And like, yeah, that's true. But when you look at this code, I think one of the things that the Swift community kind of has preached is that looking at exclamation points should kind of set off your alarms for code smell, which is not something that's not something that would be wrong, but kind of makes you feel a little icky. So Swift has some more syntactic sugar to help us get out that value. So what we can do here is we can say if let our definite Wi-Fi network equals our maybe Wi-Fi network. So what this is kind of saying is it's taking those 5 lines and condensing them into one, and it's bringing out the sum value out of the optional and making it that equal to our definite Wi-Fi network. So if I had another image in there, definite Wi-Fi network would be of type Wi-Fi network, and maybe is of optional Wi-Fi network. And so now we know inside of the if block that we can use our definite Wi-Fi network in places that requires a Wi-Fi network. And then we can handle the none case simply with the else over here. Another option is we could use guard syntax. I tend to use this for precondition type problems where we want to unpack our optional at the top of our function, and then we want to kind of use it in the rest of our function. And once we get past the guard statement, we know we have a Wi-Fi network and we don't have to keep force unwrapping it. So that's kind of what I'm thinking about with optionals. So for future investigation, there's other syntactic sugar that kind of help us deal with optionals. So optional chaining, this is a really cool way of utilizing optionals. So if we have some comment text and we don't know if it's there or not, let's say you're writing Facebook and you don't know, and somebody's typing something and you don't know if they've entered any text, and you got a label and you want to set the label's text to be that text that the user entered in, you can add this question mark here, and it says uppercase the comment text if there is comment text, and if there isn't any comment text, then don't do anything, just kind of silently move on to the next line. Objective-C had this ability where you could say if you have some sort of object, you could call a method on it, and if it was nil, it would just kind of silently move on to the next method. This is kind of allowing us to do that, and it's really nice because we actually don't have to handle the error case if the error case is just like let's move on. The problem with this and the problem with the way you did it in Objective-C is you would get sometimes where you're just like, why isn't that method getting called? I'm calling it right here. That was one of my first bugs when I had an iOS job about 4 years ago, and the comment text actually probably wasn't showing up, and it was something related to this. So the next operator is called the nil coalescing operator. It's 2 question marks, and what this is saying is if you've got a line of code that's going to kind of output some sort of value, where we want to output some value into the print function, we can say the optional value question mark or some default value, and this allows us to kind of have shorthand for handling that kind of a case.
So it's just like a default value, right? If there's nothing, then print this, right?
Yeah, exactly. And then the last thing that I put down here, it was just something I didn't have time to kind of add into the slides, but another way to use enums is to kind of model state. So we just did this minimal for another project, but and this kind of goes with at the beginning of the talk, we were lifting things out of the function into parameters. In this case, we're lifting into a type. So we're saying there's a case where we have no data, or we're maybe requesting data and we don't know if we've got data, and then we know that we have data. These are different cases for some view controller that's connected to the internet. And you could model this, right, with some optional booleans, right? Like you could say if our boolean is equal to false, that means we have no data. If it's optional and it's nil, that means we're requesting data. And if it's true, we have some data. But to just somebody looking at your code, it's not really clear kind of what all these states are. This is really kind of clearly defining what are different states. And so that's kind of another way that we can use enums. And the last point that I'll have about this is that this kind of looks like optional, right? There's a no case and then there's a some case, but then there's also this middle one. And so what we can do is kind of utilize the same kind of architecture that we have in optional to kind of create new mental models inside of our code. So that's all I got. Everything here is on GitHub, along with a playground to kind of play around with all of this code that was here. You can yourself add no Wi-Fi to UMass or create Eduroam where you don't have it. And then the last thing I have is my email up there in case you want to talk about it. So that's what I got.